Hello, everyone. I hope all of you have a great day so far at Dash today. And I also want to thank Datadog for hosting and organizing such an amazing event. When most people think of Airbnb, we think of homes sharing. Indeed, that was such an amazing idea 12 years ago from our co-founders, Brian and Joe, who pumped up airbeds in their home and hosted the very first 3 Airbnb guests who were attending a design conference in San Francisco, but were not able to find any hotel available. When the time that Brian and Joe opened their home, welcomed our guest, Airbnb community was born. That was 12 years ago. And today, when we look back, the innovation and achievement are phenomenal. In March 2019, which is just a few months ago, we celebrated our number 500 million all-time guest arrivals. And in any given night, there is an average of 2 million guests staying at Airbnb, with the choices of more than 6 million listings around the world across over 191 countries. Together, there are more than 25,000 experiences hosted by our community in over 1,000 cities. These numbers are amazing and very encouraging. However, as we are contemplating for the next 10 years, we want to make sure that we can take the same kind of innovation, scaling, maybe a little bit of magic, together with our community, our host, our guests, and bring it across the entire end-to-end trip, the entire journey. Because this is exactly Airbnb's vision to provide an end-to-end solution for anyone who travels. And this is also the motivation behind us building a Shear Platform to support our products. On top of our Shear Platform, we built multiple business units. We have homes, we have experiences, we have luxury for high-end vacation rentals, and we also have the entire entity in China. Ideally, whenever we spin up a new business or we enhance an existing category, we should be able to reuse the shared technologies, processes, user experiences where possible, because a robust foundation would enable us to expand into different businesses easier and faster. Especially when Airbnb now is moving toward service-oriented architecture, SOA. We are facing very unique challenge in front of us that during the migration period, the transition period, we have to make sure we can continuously support the product growth. And at the same time, we have to build and scale our Shear Platform in order to achieve our long-term goal. So, in the rest of my talk today, I'm going to share some of the most foundational pieces that we built into our platform from the perspective of building microservices in the same chronological order when they happened, and I will group them into 5 different principles that we followed internally, and I will share how Airbnb benefits from each one of them. Now, let's take a look at our first principle today. A shared platform maximizes the reuse of components and services. I joined Airbnb in 2016, which is the same year Airbnb started its SOA migration from a single Rails application into microservices. In order to start decomposing the monolith, we first look at the tiered architecture from Rails application. We took the bottom-up strategy, which starts from the bottom layer, the data access layer. And then we identified a few core business data models. For example, listing, pricing, and calendar availability. And then we decided, okay, let's design and build the corresponding data services that will encapsulate the database access logic into the data services. And then we can start route the traffic from hitting the database directly from the Rails application to going to the data services. And eventually, once the data service owns 100% of the read and write traffic, then we can start to perform further data model optimization or database sharding. So that was our initial plan. However, as you can imagine, building services, especially data services that requires complex data flow, is more than just migrating queries from Rails into data services. So let's take a look at an example by using one of our main page in our core booking flow, the listing product detail page. In order to display the rich content from this page, data will be loaded, will be fetched from multiple data sources. For example, from the basic listing information to the amenities, to listing pricing, and all the way to the listing pictures. This is from the product's perspective. But if we look at it from a service building's perspective, this is what we have in mind, a data flow. So assuming this is a simple data flow from an endpoint in our data service, in order to serve the response, multiple steps will be executed with a predefined sequence on top of the request. And the steps itself can be as simple as just in-memory data transformation, or it could be remote service call. If there is no dependency between steps and steps, we could potentially execute them in parallel. However, if there is dependency, for example, certain listing data will not be loaded until we confirm that a user is within a specific experiment. In that case, the steps will be executed sequentially. So concurrency is a big deal here. When traffic comes in, things are getting more interesting because not all the steps will run at the same pace. Some will run faster, some run slower. And the slow running function, the steps, will potentially become the bottleneck for the entire data flow. How do we detect it, and how do we monitor it? Failures could also happen from time to time, especially between service communication. When it happens, should we retry? Or what is our fallback or circuit breaking strategy? So even before we talk about any of the business logic, we already see some complexities here. And the very first lesson that we learned in our early days was that our feature complete code can oftentimes be quite brittle under the operational constraint imposed by SOA. In other words, without a thoughtful plan or thoughtful implementation, our feature complete code is definitely not production ready. So we summarize a few challenges in front of us at the time at Airbnb, and here are the top 3. Concurrency, error handling, and observability. We need to deal with this, especially we were still in a very early stage at our SOA migration journey. We need to build a solution into the Shear Platform in order to increase the overall reusability for the future service building. So as a team, we got together, we designed, built, and introduced the very first major service building block in Airbnb, PowerGrid. In a high level, PowerGrid is an in-house developed Java library that simplifies the concurrent data loading, and at the same time, it emphasizes a lot on publishing standardized metrics. One of the high-level design principle from PowerGrid is that we want to educate, we want to encourage the service developers to start thinking building an endpoint in a service as constructing a data flow, a directed acyclic graph, a DAG. Instead of just randomly putting functions together in the code, we want to organize it as a DAG because PowerGrid internally organizes the code as a DAG where each node is essentially a function or a step within the flow which represents our business logic. So in our simple data flow, PowerGrid introduced a concept of a node, which is essentially an abstraction around the underlying function. And on top of it, PowerGrid exposed the node-level API to allow the developers to specify things like concurrency mode or error handling strategy. For example, if today we have an input node, and we want to run 3 different nodes in parallel, here is what our service developers will write by using PowerGrid. So first of all, starting from an input node, and then we can apply the mapping functions, and then the developers can configure the node for the concurrency mode. In this example, we'll do run async, which is run this node asynchronously with a specific timeout. So in this case, the developers can focus on building a node, constructing a node, and put them together as a data flow, as a DAG, sequentially, doing a sequential, synchronous programming. And behind the scene, PowerGrid will handle the concurrency, will handle asynchronous programming, and at the same time will publish standardized metrics. Another example is for error handling. So today, PowerGrid also allows the developers to specify recovering function for any single node, so that when error happens, this specific function will be invoked by PowerGrid, and as well, the metrics will be published behind the scenes so that the developers can see what are the error counts and root cause. So to summarize it, PowerGrid allows the developers to use its Fluent API to construct the data flow and to write concurrency safe code, and at the same time, provide complete observability. So for any single service that uses PowerGrid in Airbnb, we have this centralized dashboard automatically because this will collect all the metrics by the service that using PowerGrid and expose very consistent information, for example, per data flow and per node for the execution count, latency, error count, error root cause, and a few other more information. So as PowerGrid standardized the server-side implementation and also the metrics publishing, we started to gain significant visibility toward the internals of our services. However, as more and more services being developed in Airbnb, Rails is no longer the single client that talks to our services. Instead, we started to see dependencies among the services. And here came our next challenge. Principle number 2, a Shear Platform standardized communications between components. So besides the 3 tiers that we briefly mentioned, right, the presentation, the business logic, and the data access, Rails also handles API routing and also execute the common middleware filters. For example, user authentication or user session injection, and something like risk checks, which is super important to Airbnb's business. Because all the components are wrapped within a single Rails application, so that it actually makes the internal communication simple and straightforward. However, in the world of microservices, the request lifecycle management is completely different from a single Rails application. For example, for any single request, user request coming to Airbnb, regardless of how many services it will eventually travel through, the same set of user session injection, user authentication, or risk checks has to be performed. And at the same time, we have to make sure that the user contextual information, the request context, can travel through the entire life cycle of the request. Why is that? Because there are so many good use cases that we rely on the user contextual information. For example, with the user country information that can travel through the entire life cycle of a service request, we can actually enable a location-based feature rollout based on the user country. And there's another very exciting features that our service developers rely on is distributed tracing. So with a unique trace ID that travel through the entire request lifecycle, we can enable the distributed tracing with Datadog so that the developers can visualize how much time was spent at which service in the entire lifecycle of a request from a centralized dashboard. So because there are so many use cases that Airbnb is relying on, so we have to make sure that the request context, the contextual information of a user, can be accessed and also be propagated with the request. In order to do that, we have to standardize the communication between service and service, right? So in Airbnb, we built an end-to-end solution starting from an API gateway. So API gateway is a service layer that provides request routing, the API routing, and also the middleware platform. This is also where the request context is formed. So from a high-level architecture's perspective, so in high level, an API gateway is, it guards the entry to the internal, for the request to the internal, Airbnb's internal services. And at the same time, it allows the developers to register additional middleware filters. So API gateway allows the developers to register additional middleware filters. So once the execution results coming back from the middleware filters, API gateway will extract the execution results and form a request context object, and then pass into the internal services by HTTP request headers. So in order to define the request context information, we have to use a standardized way to define the schema, right? So in Airbnb, we utilized Thrift IDL to define the request context structure. So IDL stands for Interface Definition Language. So we use IDL to define the schema. Maybe we'll just go to the next slide. Yeah, that'll be fine. Cool. Thank you. So for the request context schema, we can define multiple available attributes, each one with its own strong type. And we also use annotation to specify what is the request header key that will be associated with the specific attribute to be used when it's being propagated. So once we have the schema being defined, last thing we need to do is we have to put them together. We have to propagate it through the entire service call chain. So in Airbnb, we built a standardized RPC Service Client. So RPC Service Client is more than just an HTTP client wrapper. It does a lot more than a traditional HTTP client wrapper. So first of all, it performs request, response, communication. And also, it propagates the request context. Beyond that, an RPC client also handles exception handling because it knows how to interpret the response code from the server side so it can take proper action. And of course, we can utilize RPC client to enhance the security level between service communications. And overall, all the standardized metrics are published from the RPC client, so we can always get the complete observability from the client's perspective to monitor the performance. So quick recap for this one. So we built an API gateway, standardized the request context definition, and we use RPC client to propagate the request context. So overall, we standardize the communication between services. So right at this point, building services, creating services has become much easier in Airbnb. But our next challenge was, how do we ensure a higher level of productivity for our service developers? So here comes our next principle. Principle number 3, a Shear Platform increases development velocity. So ideally, this is what all the service developers should only focus on, right? Business logic. This is what provides the business values for all the service developers. However, at the time at Airbnb, this was what we expected our service developers to implement. A lot of the plumbing code and the skeleton code from both the client and server side, right? So usually under the constraint of resources or deadline, this was what we end up having, which leaves our service development in an inconsistent and incomplete stage, which is not ideal. So one question that we asked ourselves was that, how can we ensure a much more efficient development flow? How can we automate as much as possible for our developers? So in Airbnb, we took the approach of schema-driven service development flow, which we built an IDL-based service development flow, and IDL, again, stands for Interface Definition Language, and this is built on top of Thrift IDL framework. So if we look at our development flow now, the very first step our developers need to focus on is define a schema for both the service API, data model, and also the request response structure in Thrift. And then by utilizing Thrift framework, we will generate the data objects that we can also use to integrate with PowerGrid. So at this stage, the developers can focus on writing business logics. And then since we have the service API defined in Thrift as well, then the client-side code can also be generated together with our RPC client. And of course, the schema will drive the creation of the documentation, dashboard, and all publishing the metrics. So let's take a look at an example to see how we put all of them together. So let's say today we are building a listing data service. And the first step we'll focus on is define the listing data model, right? This listing data schema. So we use Thrift to define a listing structure with all the available listing attributes. Each one of them has its own strong type. Attribute and strong type. Yeah. And then we can put together, by using our existing data model, put together a request response structure, because this will be used in our endpoint that we create. And once we have the request response structure, service API is ready to be built. So we have service name, my service, and endpoints. For this example, we have load listing by IDs, and we have request responses, so input output for the endpoint, and we can also use additional information to define things like SLO, service level objective, so that our framework will know how to generate alerts and metrics based on the SLO definition. So once we have the schema defined, we can generate all these data objects that we can use in the server side. But one of the most exciting features that we also introduce is that the documentation are also being generated as well. So for any single service in Airbnb, we have such a single central place for any developers to view the information. And all this information are schema-driven. For example, if you want to integrate with my service, first of all, you will take a look at what my service provides. And if you want to integrate with any of the endpoints that we provide, here are all the information with endpoint name, request, response, and all the available attributes and their type. And one of the cool features that we introduce is, what if we can send out a request directly from this page? So we allow the developers to plug in certain testing requests from here, from this user interface, and to get a sense what the response look like. And this is through our development environment. So this end-to-end development flow increase overall the experience for our developers. And of course, we mentioned the metrics as well. Since we also publish standardized metrics, so we build a standard server-side dashboard. Server-side dashboard. So with the filters on top, our developers can easily navigate between service and services. And since all the information are unified from this specific dashboard, So we group the information into different sections. The developers can easily to consume the data. And of course, the client side, we have the same filters on top and the grouping for the information. And overall, we provide very consistent information, again, between the server side and client side. A quick recap again. So by utilizing IDEO-based service development flow, we greatly increase the velocity for our developers. But development is not just about coding, right? Coding is a big part, but there are times we have to take or have to follow certain processes. And especially if we talk about SOA migration, chances are we have to run certain data comparison to ensure parity between two code paths, like old code path and new code path. Since this is such a common practice, so in Airbnb, we also focus a lot on the process, and let's take a look at our next principle. Principle number 4, a shared platform streamlines the development and operational process. So to further illustrate this principle, let's take a look at an example. So this is like Airbnb host side listing editing product flow. So from this page, the user can edit the listing policy from the check-in time, check-out time, and cancellation policy, and a few other information. And once the save button is clicked, the information will be persisted. Before our SOA migration for this specific product flow, this is what happened after the save button is clicked. So Rails still gets a request, and eventually the request will be routed into data services for data persistence. And our goal is to come up with a service counterpart so that eventually, once we have this services being developed, we can route the traffic to going through our services directly. So that is our goal. But as you can imagine, in able to do the traffic cutover, we have to ensure the accuracy and also the feature are identical in the two tracks. And if we have tens or hundreds of such product flow, this comparison could take a lot of time and very repetitive and tedious work. So in order to achieve a better efficiency for our developers, in Airbnb, we came up with offline request payload-based comparison framework to facilitate this comparison. So in this approach, we'll set up a staging environment for comparison purpose, but instead of just comparing the database state after the write operation, we actually compare the request payloads collected from the data service. So let's take a look at how it actually works. So let's say this is the product flow we want to migrate. And we then implement the service counterpart. We have, depending on the ownership and complexity, a single request may travel through multiple business logic services before hitting the data service. And in order to do the data comparison, we will set up a staging environment so that we can instruct the API gateway to perform and request replay, the staging tier replay. So in this case, we will replay exactly the same request to a staging tier. And within the staging tier, we have staging services and staging database. Because the request is originated from the same user request, so the request contains exactly the same the request context, and also a request key, which is unique to the request. And once the data service receives the request, what it will do is it will publish an event to a queue. So for a production data service, it will publish to a production queue. And for a staging service, to a staging queue. And within the event, it will contain a request context, exactly the same request context the data service received. And also, it will include the request key. So that once the event's been published to the queue, our offline comparison framework will consume the event. So basically, it's essentially a data pipeline. It will collect all the events with the same request key. And then it will merge the payload. And then you will compare the payload between the two environments, two tiers. So once the comparison result is done, it will be written to an offline table. It's a Hive table for the complete audit log for offline queries. And also, the metrics will be published to Datadog so that the service developers can easily view what attributes are matching and what are not. So after this framework's being released, a lot of our engineering teams are actually using these frameworks to do the comparison. And this gave us a lot of benefits. First of all, it separates the concern because now the developers only need to focus on business logic and also implement the comparator function, not the entire infrastructure. And also reduce the risk because the traffic now is replayed through the API gateway level. So we can eliminate a lot of the potentially human error. And of course, the best out of this is the performance. The comparison is done in offline so that it doesn't add up additional overhead into production. And of course, observability. All the metrics are published from the framework so that engineers can easily view the metrics for the comparison result. So another quick recap. So far, we have been talking about building shared, the foundational pieces into the Shear Platform, and it will hide all the implementation details and standardize the server-client communications and also the development flow and observability. But in order to grow our Shear Platform into the next level, let's also take a look at the area that Airbnb also spent a lot of time in the last couple years. Principle number 5, a Shear Platform builds for extensibility, scalability, and resilience. So one of the common incident patterns in the past in Airbnb, especially in the first few years in our SOA migration, was that the server side was vulnerable to the incoming bursty traffic. So it usually caused server-side resource exhaustion and then cascading call chain failures. Along the years, we have been building multiple service resilience mechanisms into our systems. And one very important lesson that we learned from our experience was that the service resilience is not just about the client-side implementation, and it's not just about server-side either. Most of the time, it's about effective communication between the client and the server. For example, request queuing is a very common strategy or implementation in the server side to absorb bursty traffic. The idea behind that is before a request being handled by a worker thread, it will be first put into a request queue with a specific timeout in the queue. In Airbnb, we implemented our request queuing mechanism with a slightly variation by combining control delay and adaptive last in first out, so that during the service is experiencing high load, the control delay will kick in, so that instead of assigning a fixed timeout, this time it will assign a much smaller value for the timeout, in this case, 10 milliseconds for the incoming request. And at the same time, we will reverse the processing sequence from first in, first out to last in, first out. So in this way, a much smaller timeout will prevent the request queue from continuously growing. And the reversing of the sequence will favor the last in request so that it will increase overall successful rate from the server side. However, the first in request still has a very high chance to time out, right? So eventually it will be rejected or be discarded by the server side. So that the client, if the server is still returning a regular 500 error to the client has no idea what's happening in the server side. So here comes our next implementation, which is back pressure propagation. So back pressure is actually a signal that the server sends out to the client to say, I'm currently under heavy load, so please take some proper action. So that it will, by using this effective communication between the client and server, we actually give the client much more information. For example, if today we have 3 services, and service C is currently under a certain heavy load. So instead of returning 500 as a status code, it will return a mutually agreed 529 back to the client. So when the client receives it, it understands that, OK, this is a back pressure from the service C. So that, first of all, I'm not going to, OK, let's go back, assuming that you memorize it. Yeah. So that it is a back pressure. I'm not going to retry because I want to prevent a retry storm. And at the same time, it will propagate the back pressure back to the upstream so that within the entire service call chain, no one will ever retry on this specific request, which will give service C a chance to recover. OK. Cool. And then another very closely related mechanism that we built into Airbnb is that API request deadline. So for any public API, any single public API in Airbnb, we assign a carefully chosen request deadline budget. For example, a request can have a budget of 2 seconds, which means within the entire life cycle for the request, all the services, whoever will process a request, has to share this 2 seconds. So in the service side, before we process a single request, we will check whether the request has expired for example, 2 seconds. If it is already expired, then the server side will not even spend any additional resource to process the request. And at the same time, if the request will be rejected, it will send out a mutually agreed status code back to the client, so the client will know what's happening, and it will propagate it back to the upstream. So both of these, just examples, just let you guys know, the communication between the client and server is very, very important. We have to let the client know what's happening so that we can take proper action to protect the server. So in Airbnb, service resilience is not a feature. It is a requirement, which means we are continuously building the resilience mechanism. We are learning from our system and building back to our system. Overall, we want to achieve a much better user experience for our end user. So to wrap up, to conclude all our 5 principles today, I want to share 2 takeaways for all of you. First of all, everything we build matters. So when we build for production, because platform transformation requires a long commitment and strong discipline. So always avoid the temptation to cut corners in the face of a deadline, because that could potentially put our platform at risk. So when we build for production and never jeopardize the shared resource. But that doesn't mean we want to over-engineer everything, because over-engineering can usually increase overall complexity and increase the time to ship. So when we scale for tomorrow, always have a straightforward story about your scaling plan. What is your plan for next 6 months, next year, next 2 years? So when we scale, consider about 3x, 5x, but not 20x or 50x. But if you expect your service to grow 50x in the next 3 months, please let me know. I'll be very, very interested. OK, so build for production, scale for tomorrow. And Airbnb so far has a very, very positive experience during our platform transformation. So my name is Victor. I want to thank you for joining me today and listening to our story. Thank you.